This is the first of the mini-series on the trig identity for the angles of a triangle. A, B, C are the three angles of a triangle. Then we have the identity here, the sum of sine equal to 4, the product of cosine of half angles. So what is the proof? The first thing we know is that they sum up to 180 degrees or pi in radian, in which case we can express C into pi minus A plus B. We know that for the sine of C equals sine pi minus, the quantity is going to equal to sine A plus B, right? So when two numbers add up to pi, the sine value are the same. So here, sine A plus B. What we can do is rewrite this with the replacement of sine C here, which is A plus B. We use the trig identity for sine of the sum. Sine A cosine B plus cosine A and sine B. Now you can combine the term here for sine A and for the sine B. Let's do that. So we take common term sine A. What we get is 1 plus cosine B. And for sine B, you get 1 plus cosine A. Now here we're going to use double angle. Some people say it's half angle. So that is, for this quantity here, is going to be 2 cosine square B over 2. For this quantity here is equal to 2 cosine square A over 2. So let's rewrite the whole equation here. So we're looking for some expression in the half angle here, right? Here we have a whole angle we're going to replace with double angle quantity here. So that would be equal to sine A over 2 cosine A over 2 times 2 cosine square B over 2 plus, similarly, we use double angle. All right, we're getting close. We need to have this term here eventually, right? 2 by 2 is 4. We have cosine A over 2, cosine B over 2. All right, it's a common term. Let's take it out. So that would be 4 cosine A over 2, cosine B over 2. And then what we left here is going to be sine A over 2 here. And this is going to be sine B over 2. And because this is square, there's one more term here. So we're left with sine A over 2, cosine B over 2, sine B over 2, and cosine A over 2. All right. So here you recognize this is going to be the sine alpha cosine beta, cosine alpha, sine beta. Sine A over 2 plus B over 2. All right. So this is come to this carry over. So what is the term here? We want to turn that into cosine, right? Because the right hand side is here, right? A, B, C are the angles of a triangle. We know that A plus B plus C equal pi, or if you divide by 2, so A over 2 plus B over 2 equal pi over 2 minus C over 2. So in that case, sine of this quantity equal cosine of C over 2. Okay, this part equal cosine C over 2. So we have the proof. So that is the sum of the sine value through the application of the trig identity here, half angle or double angle here, and then the sine of sum. So we have the final equation, which is 4 cosine A over 2, cosine B over 2, and cosine C over 2. So that's the proof. We would like to prove a related identity. If we change this to minus, this used to be cosine, we change it to sine. In the first part, it is plus where everything is cosine, and then if we change to minus here, that's sine, and this is cosine. So what's the proof? This used to be plus, now it's minus here. Now 1 minus cosine b, this is going to be sine square instead of cosine square half angle. Alright, so let's take out 4, it's common factor of sine a over 2, sine b over 2. What you're left with, in the first case, sine a over 2 and sine b over 2, you have one more. So you have cosine a over 2 and sine b over 2. Plus, in the second case, you have take out sine a over 2 and sine b over 2. You're left with cosine b over 2 and sine a over 2. This quantity here, it is sine a over 2 plus b over 2. Same reasoning earlier, right? So this part here is going to equal to here, right? However, the other factor changed to from cosine to sine. Okay, so that's the proof. But let's look at another proof based on the first result. So from this identity, we have to change plus to minus. So this one, we have to minus 2 sine c here. So 2 sine c with double angle quantity here. For this part, equal 2 sine c over 2 cosine c over 2. So this becomes minus 4 sine c over 2 cosine c over 2. And you're going to take out the common factor here, right? 4 cosine c. So we have 4 cosine c over 2. And then what you're left with? Sine c over 2. Earlier, we have this relation here. Half angle add up to 90 degrees. So replace this with cosine. So this part equal cosine A plus B. So we use cosine formula here. Cosine, cosine minus sine, sine. And this would cancel, left with minus, minus would become positive. So finally, we have the desired form. So that's equal 4 cosine c over 2, sine a over 2, and sine b over 2. So that's the equation here. In this series, we're going to cover a few identities for angles of a triangle. You may find them useful in some of the advanced math problems. For these and other interesting math problems, please like, share, and subscribe to the channel.